Hello everyone, for this tutorial video I'd like to explain how to figure out surface area of solids of revolution. If we rotate a function around an axis to get a solid form, like with Calculus 1, but we stop to divide it into sections, where the curves are approximated with line segments, we can see that we can divide the solid into smaller solids called frustums, or sections of cones. And the surface area of each frustum would be 2 pi times radius times length, whereas a trapezoidal shape, the radius would not be a constant, but rather would be 1/2 radius 1 plus radius 2, which are the different radiuses at either endpoint. We see one radius would be a function at a specific point, so the other radius would be the function before that, and the length of the frustum would simply be the line segment. Since we know already a formula for the line segment, we can next assume the function at either endpoint is approximately equal to the function of any arbitrary point between these, which allows us to simplify the radius of each frustum into one term rather than an average of 2 terms, and plug in the arc length formula for the length of each frustum, and don't forget the 2 pi. So now the surface area is the area of all these frustums added up, and as the sum tends toward infinity, we get the exact surface area, which has an integral in this. Like with arc length, if we had x equals function of y, we would use h of y and the derivative of that instead of function of x, but the surface area formula would be the same in general. Now that we have figured out how to find surface area of complex shapes using integrals, we can explain how you can use integrals to figure out the center of mass next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.